Okay, there we go. All right, so just so y'all know, we have somebody that's not here today, so I'm gonna be recording it so that they can watch what we're doing at home and not get fall behind. Okay.
And you decided to take her spot, and you did. Dang.
And if one of y'all ever has to be at home, you'll have that available to you so you don't miss the lessons. Okay. Now, as far as like tutorial help, that may have to wait till y'all come back if you need help with stuff. Because it's gonna be really difficult to tutor calculus over the internet. Okay, so, but at least this way, you're at least getting what I taught everybody. And you can attempt the homework, and if you get stuck, then you just hold on until you come back and we'll answer the question when you come back.
Pre-calc was a roller coaster.
Difficult to learn.
Yes, yes. Imagine how much harder calculus would be over the internet.
Oh, no.
So that's why, you know, I'm gonna do the videos when people are out. Only when people are out. I'm not gonna record it if nobody's out.
I missed the first time we were forced to stay home. Teachers were kind of like, this is
Okay.
one assignment for 2
So-
weeks.
Again, as y'all saw in 1.4, just about the entire section we'd already talked about, right? We'd already talked about one-sided limits, right? We'd already discussed all these joint discontinuities, right? Like jump discontinuity and infinite discontinuity, right? Removable we'd already talked about all that. So the really only new thing in that last section was continuity, right? Proving that something was continuous. But all the other stuff we'd already done. Well, this section has pretty much the same thing. A lot of the same stuff we've already talked about with a couple of new things, okay? So that's why seems like we're moving a little faster, is because you already know how to do all this stuff, okay? All right, so what is an infinite limit? Well, we've already discussed this, right? It's a limit that goes to infinity or negative infinity, right? And down here at bold, I say again, don't let the equal sign confuse you, right? This limit does not exist, right? And what do we say? Because it breaks the rules of limits because of unbounded behavior, right? Again, you've already seen this. All right, we've already been dealing with this. So here's the graph for 1 over x. This is what's called the reciprocal function, okay? And as you can see, when we come in from the left, it goes down to negative infinity, and when we come in from the right, it goes up to positive infinity. So this one has several different things it breaks, right? Left and right aren't equal, so the limit doesn't exist.
Jump, no.
It would be considered a jump or an unbounded behavior. It could be both because it's jumping to, right? So I would just say left and right limits do not agree, therefore the limit does not exist.
Okay.
But it actually is right? It goes up to infinity, so that doesn't exist either. So there's a couple of things here that cause problems, right? Vertical asymptotes. So this you do need to know vertical asymptotes. Okay? So this says if a function approaches infinity or negative infinity as x approaches c from the right or the left, then the line x equals c is the vertical asymptote of the graph. You guys already knew this, right? If we go back to this one, what is the asymptote at? X equals 0, right? Right? You guys already knew that. This is just saying that if a function as it approaches that value goes to infinity, there's an asymptote there, right? But you already knew that. Okay? So this is what's important. So if f and g are continuous on an open interval, right? And there exists an open interval containing c such that g of x cannot be 0 for all x equals c. So what is this saying, right? This jargon that we just read, okay? Well, it says that if g of x is 0 and f of x is equal to some value, we get an asymptote, okay? So think of like this function right here, okay? This is your g of x and 1 is your f of x, right? So what do I get when I put in a -1 there? I get a 0, right, in the denominator. So that's telling me if I put a 0 in the function and the numerator isn't 0 and the denominator is, you get an asymptote. Okay, does that make sense? So here we get an asymptote at -1. Why? Because when I plug -1 in, I get a 0 in the denominator, but I don't get a 0 in the numerator. Does that make sense? If you get a 0 in the numerator, then we got a problem. Okay, you
You
can't.
said you could never have 0 in the denominator no matter what.
You can't. That's where we get the asymptote. We're
That's
just.
what it's just you're saying just to have some.
I'm proving that there's an asymptote here, without looking at a graph, right? Before, you guys always wanted to look at the graph to see where the asymptotes were, right? Now we can state where they are without looking at the graph, right? If I go right here and I plug a -1 into this equation, what do I get? I get 1 over 0, right? If I get a 1 over 0, that tells me there's an asymptote at -1.
What would it be if it was 0 over 0?
Then you would have to do some more work.
You would have to do like the stuff we did in the last unit.
Yeah, we're gonna go on to that in a second, okay? All right, so what about this one? If I plug a 1 in, definitely get a 0, right? If I plug a -1 in, I definitely get a 0. What about the numerator?
A negative.
You can't do
You
it.
get 2 and 2. You get 2 and 2, right? -1 squared plus 1 is 2, and 1 squared plus 1 is 2. So where are my asymptotes? At -1 and 1. Right? Because at both of those options, I still get a number in the top and a 0 in the denominator. Okay? Does this make sense? So again, the thing you need to take away from this whole asymptote business. If you get a 0 in the denominator, is that always an asymptote? No. Only when you get a 0 in the denominator and not in the numerator. Does that make sense?
So you can have like 0 over 2, that's fine.
That would be 0, yes. Yeah, so if you get a 0 in the numerator and a number in the denominator, that answer is just 0. That's okay. It's only the denominator that's the problem, and if you get a number up top and a 0 in the denominator, that's the telltale sign of an asymptote. Okay? This one, where's my markers? If we look at cotangent x, oh, this one's dead. If we look at cotangent x, cotangent is sine over cosine or cosine over sine?
Cosine over sine.
Cosine over sine, thank you. So, where would we get a 0 in the denominator? At what angle? When is sine 0? When,
At,
0? Yeah, at 0. And
1, negative.
pi. And then we can just keep going around, right? 2 pi, 3 pi, right? So at every half circle, the y value is 0, right? That's what that's listing out. So we can say when x is pi times some number, that's when we get a 0.
Pi
Okay.
comes from.
Yeah, because 0 times pi, 1 times pi, 2 times pi, right? All the pi's, that's when I get a 0 in the denominator, right? Because that's when sine is 0. But the cosine of 0 is 1. So we get a number up top, 0 in the denominator, that's the problem, right? So at all of these, I have asymptotes. Okay? Not too confusing, right? Okay.
Wait, what's after the pi?
And just in some number, a constant. It would have to be a number, whole number, right? So, you know, like an integer. An integer. Think of n as an integer, that's a better way of thinking of it. Okay, so let's look at this one. Because this is one where we don't get an asymptote for one of the numbers. So remember what I said earlier, if the number gives you a 0 in the numerator,
You're gonna have a problem.
then the numerator, that doesn't mean asymptote, right? You have to get a number up top and a 0 in the denominator. That's the only way to get the asymptote. So this is one that deals with that. So right away, everybody should see that, right? Right away, you're going, that's difference of two squares. I know what that factors to.
And then you get 4 and -2.
Yes. Yes, brother. So, right away, you guys are thinking, hey, 0, asymptote at 2 and -2. But that would be wrong, okay? So, Riley says the numerator factors to x plus 4x minus 2, and she is correct. So, what happens at 2?
They cancel out.
That's right. At 2, we end up with a 0 over 0. That does not tell me asymptote. Okay? You see what I mean? So, if a 0 pops up here and in the denominator, that does not mean there's an asymptote there, right? It has to be a number up here. Okay? And yes, Fernando, those cancel out. So, when we cancel, we just simply say x cannot be 2. But that does not mean there's an asymptote at 2. It means there's probably a hole in the graph. Okay? Does that make sense?
Mm-hmm.
So far? So, now what can x not be?
-4.
-2, and at -2 I get a asymptote. Right? Because look, I get positive 2 over 0. Number over 0, asymptote. Does this make sense?
No.
So x can't be positive 2 either, but there's not an asymptote at 2. There's just a hole in the graph.
Wait, so repeat what you just said.
So if we plug in a -2, we get -2 plus 4, which is positive 2, over 0. Asymptote right away because we have a number over 0.
So whatever you plug in, you do it to the bottom, and then just do it at the top.
That's right. So you're looking for the zeros in the denominator, but they can't also give you 0 in the numerator. When we plug positive 2 in, we get 0 times that over 0 times that. That's not an asymptote. We're just looking to see if there's an asymptote there. Okay? So don't think that that's not a problem with the function. It is. But it doesn't cause an asymptote. It just causes a hole in the graph. Okay, and we're strictly worried about asymptotes right now. Okay? When we get to the end, if I got time, I'll show you the graph of that one, and you guys will see. Okay, so properties of infinite limits. So this is where, you know, what I've told y'all before. I think I told you last year, when we started talking about this whole concept of infinity. So what this says is the limit of f of x is infinity and the limit of g of x is L, some number, right? So if I have the limit of f of x plus g of x, well, I already know the limit of f of x. It's what? It's infinity, right? And the limit of g of x is some number L. Guys, infinity plus L is still just infinity. Okay? So it doesn't really matter. This L, it doesn't matter. It's irrelevant. Okay? Because infinity is not a finite number. It's just an idea, right? And if you take infinity and you add some finite number to it, you're still just get infinity again. Okay? And that's what all of these are saying, right? This one right here, I end up with infinity times L. Well, infinity times any number is still just infinity, right? Here, if L is negative, then it's infinity times negative L, which is negative infinity. You see what's going on here? It's you guys already know this, okay? And then here, this is an important one, the quotient. So here I get L over infinity. So here I have a finite number divided into an infinite number of pieces. How big are the pieces? They're non-existent. This is a big one for people to swallow, okay? Like, difficult to take this and go, okay, yeah, I'm good with that, right? But that's what's happening here. We're taking something finite and making an infinite number of pieces out of it. How small are the pieces going to be? Non-existent. 0. Okay? Yeah, I know this one's tough.
It's
This
just
one,
a concept.
this what?
It's just a concept.
It is. It's just a concept that if you take something finite and you divide it into an infinite number of pieces, then the pieces are infinitely small. And how do we say infinitely small? 0. Doesn't exist.
You don't just write does not exist.
No, because it does. It's 0.
You just said it doesn't exist.
Just think of it as it does. It's just so fine, so infinitely small we don't worry about it. Is that better? Is that better to make it a little more easy to deal with? I get that this is a very difficult thing to take in, okay? But that's the way it is.
Is it gonna show up a lot?
Yes. And this concept of dividing by infinity.
It's
Yes.
always just
Isn't it easy then? Because we just put 0.
Yes.
Wait.
As long as it's not.
Don't add something.
As long as it's not that one. Okay, we're not
That
there
one's
yet.
just one.
Don't get ahead of ourselves.
Is that
Answer,
one just
Jasmine.
one?
Yes. What's your question, Jasmine?
I was gonna ask
That the infinity over infinity? Yeah, we'll get there. Okay, I don't want to put that on y'all today.
Is it just one?
We're not gonna get there
Is
today.
it just one?
Pieces at a time, guys. Let's get y'all over this bump, and then we'll deal with that bump later. Okay?
So you can add, multiply.
That's right. If you add, multiply, or subtract,
What if the infinity's on top?
then it's infinity, right?
Okay.
Because you're taking an infinite number and cutting it 3 times. It's still an infinite number, right?
I see.
Right? This one is infinity. This one, 0.
What about infinity over infinity?
Yeah, we're gonna worry about that later.
I want to know.
Why can't you
There's
just
a
tell us?
reason I'm not showing you. You need L'Hopital's rule really to deal with
You
infinity,
said what?
infinite limit over infinite limit, and so
Your time.
we will get there. Not right now, okay? All right, I got an example I want to show you.
Does it involve the
For this,
Does it?
No.
With the
Um,
homework. I wasn't ready.
I told y'all it wasn't gonna take me long to get through this one.
Wait, hold
Limit.
on, I'm not ready for that.
All right, let's look at this one. Limit as x approaches 0 of 1 plus 1 over x squared. Okay, so we already know that we can break this into 2 separate limits, right? The first one will be the limit as x approaches 0 of 1 plus the limit as x approaches 0 of 1 over x squared. And everybody right now knows that that's a problem, right?
Yeah.
Okay? Yes? Okay, what do we get here at 0?
1 and negative 1. Oh,
We get 1 over 0, which is a asymptote. Right, see, we're learning it. Okay? So, now, it's definitely either going to positive infinity or it's going to negative infinity, right? Now, as I come in from the left, my x's are all negative, right? So I get 1 over a negative number, which would be negative infinity, right?
So the denominator determines the, or no?
Isn't that both of them? So it's not. It doesn't.
I know, I'm doing both left and right,
Oh, okay.
right? And then we come in from the right, and it would be, so if this, let's do this one as the negative. And then if we're coming in from the positive, it would be
Positive.
up, right? So up to positive infinity. Does that limit exist?
No.
No. Okay. Now, what if I just wrote it like that,
Then yes.
right? With the negatives. So what would this limit be then? It would be 1 minus infinity, which is negative.
Wait, where'd you get the 1 from?
That's what I'm saying.
Right there.
Yeah, but like, what does it have to do with that?
We're adding these two
Oh.
limits. So this limit is
I
1
see now.
minus infinity.
Why is it so far away from the rest of the equation?
Well, I just broke it up and I go, well, I just wrote it too far apart. No problem. My fault. Here.
So anything
There
minus,
you go.
so anything minus infinity is still gonna be negative infinity.
Yeah, because it's negative infinity. 1 minus.
What if it was infinity minus something?
Hmm?
If it was infinity minus something, is it just infinity?
Infinity minus any number, any finite number would be infinity.
But negative infinity minus negative.
Don't worry about the double infinities, okay? Let's stay away from those right now. We'll get there. Okay? Alright, let's look at another one real quick and then you guys can.
What about negative infinity minus negative infinity?
If you had any questions on the previous homework,
Many.
Oh, I had some
Homework? I
questions.
just need a refresher
Homework.
again.
The previous one.
yeah.
Oh, from the weekend?
Yeah.
Alright, let's do the
I was
limit.
able to do that.
As x approaches 0 of x squared plus 1 over x. And this is the negative. The limit is the left-hand limit of this guy. So, what's the limit as x approaches 0 of x squared? That one's easy. Just plug that in, right?
Yeah.
0.
0.
What's the limit as we approach
Asymptote.
asymptote for sure, right? And if we're coming from the negative, that means all our x's are negatives, which means it's negative infinity. Good. You guys are getting this. That's the biggest thing I needed y'all to understand today. The asymptote happens when you have a number divided by 0. And then you get, when you combine infinity and a number, you still just get infinity.
Are you sure?
I'm sure.
Are you really
100% sure.
Where'd you get that from?
From me.
Oh, what was that?
You guys good?
Oh, I think you said you got $20.
Okay, questions on the homework that was due today?
Okay, what homework? Many.